Hello everyone, let's solve this problem LeetCode349 intersection of two array. So for this problem, let's read this question. Given two integer array names 1 and names 2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. So here shows that unique. That means we probably will use a set or maybe a hash set to store the result. Okay, here is the example. The input here has a two array, and then we will return 2 because we have see this one we have a 2, right? So that's the intersection between the numbers 1 and the numbers 2. And another example we can see numbers 1 is 4 and 5 and numbers 2 is 9 4. So we check this one, the none is in here, so none here, and check another one, 4 is here, and then so kind of, and then we got the result none and 4. Okay, this is the problem. So for this problem we have different ways to solve this problem. So the first very naive way is a brute force algorithm. So for the brute force algorithm, let's just do this. Okay, so for the brute force algorithm, so what we do, this is the numbers 1, numbers 2, and a pointer I, pointer j. So what we do, we choose the I equals to 0, the number is 1 here, and then we check if the in the numbers 2, we do have a numbers 1 or 2, so we just iterating. So here, no, it's not equal, and then not equal, and then we add plus plus, and then we check again from the numbers 2, and also kind of. So the time complexity for this problem is gonna be times n. Okay, so because it's a brute force algorithm, we have other algorithm is more like a save the time and space. Let's talk about that. Okay, here. Okay, so we can use hash set also. So what we do the hash set if we have this, let's do this. Okay, this is an example. Okay, here's the example. So hash set, first we compare numbers 1 and numbers 2, find the smaller one as numbers 1. So we can see numbers 1 and numbers 2, the smaller one is numbers 2, right? So what we do, we iterating numbers 1. Here is numbers 1. This one is numbers 1. Okay, we just do what we do. Let's give this example. Sorry about that. I think this example is more kind of. That one is too simple. Okay, first we compare numbers 1 and the numbers 2. So which one is the smaller? This one is the smaller. And then we iterating numbers 1 and create a hash set for the numbers 1. So let's do numbers 1 hash set. Okay, this is the name. And then we iterating every single element and we put it the hash set. So let's say 4 9 5 because it's not a duplicate, so it's 4 9 5. And then what we do, we iterating every single element in the numbers 2. We will check if numbers 1 side here contains numbers 2. So let's check. So for here, none is none in the in this numbers 1 side, this hash side. Yes, if contains numbers 2i, then we include a shared atom to the intersection. So for this one, the intersections is gonna be none. Okay, and then let's do this way. We are iterating here. Okay, so and then we check the 4. Is 4 inside is numbers 1 side contains atom 4 here? Yes. And then we put 4 here. Okay, and then we check one more time. This 9 is none. Is numbers 1 side contains this element 9? Yes. we supposed to put in the intersection, but intersection we already have set, so we will keep this result. And then we iterate. We move the pointer I one more step ahead. Okay, so here is an 8. We take 8 in within the numbers 1 side. No, then we iterate. And then this 4 is 4. Is numbers 1 side contains 4? Yes. And then it's already in the intersection, so we don't have to update the result. And then I plus plus. So this is basically the algorithm for this one. Let's start a code. Let's do how do we code this problem? Okay, so what we do first, we have a corner case. We check if numbers 1 equals to none, and numbers 2 equals to none. If numbers 1 or numbers 2 equals to none, what we do here, we return none. Okay, this is what we do. And then we check, we compare the numbers 1 and the numbers 2, which one smaller, like here. Okay, found the smaller one. So what we do, numbers 1 dot length. If numbers 1 dot length greater than numbers 2 dot length, okay, so what we do here, we do a swap. Okay, kind of. Okay, this is numbers 1 and the numbers 1. We give numbers 2 to numbers 1. Okay, this is numbers 2, and numbers 2 equals temp. Okay, so basically we compare the numbers 1 and numbers 2. So we give we found the smaller one. The smaller one will be the numbers 1. Okay, this. So why we do this? Because if we don't do this step, it's also fun. But if we do this step, what we're trying to do, we're trying to put the shorter one, the smaller size one, in the hash set. Okay, it can really save the space, the extra space. Okay, so and then here is a set with the name. We can be numbers 1 set, right? And then we new hash set here. Okay, we new a hash set here. Okay, what we do, and another one. This one, the name is intersections. So we are trying to put the result in the intersection here. So I equals to 0, I smaller, numbers 1 dot length, I plus plus. Okay, so this part basically we are iterating the numbers 1. We put the numbers 1, the element to the numbers 1 side. It's a hash set. Okay, it's basically is this step. Okay, we put a phone 5 to the numbers 1 side. Okay, and then we iterate the numbers 2. And smaller than numbers 2 dot length, I plus plus. Okay, so we check if the numbers 1 set, okay, contains. Okay, here is dot. So we check this one if it contains our numbers 2, numbers 2, because we are iterating all, we are traversing all the element from the numbers 2 now. So if our hash set already contains the element in the numbers 2, then what we do, we put it in the intersections at there's the numbers 2, okay. This is what we do for this problem. So after we iterate all the element in the numbers 2, what we do, we just simply return the result. We just simply return the result. This is here is a for loop, and then here is this one, and then we just return. That's a for loop. Okay, for loop. And then we just return here intersections. Here actually is a Java 8. So we have a string map to int. Okay, here is a Java 8 function, the string function map to int and then to array. Okay, so if you are not familiar about this method, you can Google it, map to int. Okay, this is basically we are trying to convert the result from the hash set. This is hash set to a integer here. Okay, so we are gonna to array. Okay, here is a different method. You can search it about the map to int if you are not familiar about it. Okay, so let's run the code. Oh, it's not working here. Yeah, let's do this. Let's run the code. Oh, here is numbers 2. Sorry about that. Okay, it's accepted. So the time complexity for this problem is gonna be m o big O m plus n. So why? Because here we can see we iterate the numbers 1. This is o n plus we iterating we traversing the numbers 2 as well. So here is o m. So that's why the time complexity is o m plus n. Okay, talking about the space complexity, we can see here we have a set, the numbers 1 set. We put all the elements in this set, the smaller one. So the space complexity will be O(n). N is smaller than m. You remember here we just compare the numbers 1 and the numbers 2, and then we just pick the numbers 1. The here and then choose a smaller one, so as on. So but the om actually here we are not consider this one because the intersection actually is a hash set we are using to store the result for our algorithm. So we are talking about extra space here. We are talking about the space complexity. Actually, it's extra space, so we are not consider the n here. So that's why the space complexity for here is on, because our algorithm only used on this extra space for this algorithm. Okay, thank you for watching. I will see you next time.